for some people to join in. Should begin in about a minute, so thank you for those that have already chimed in, and we'll get started very quickly. Looks like we have a couple more people joining in. Just kind of waiting for them to load in, and I'll start the presentation. Just out of curiosity, can everyone see and hear the audio well? Thank you. All right, so I'm just going to go and share my screen so that everyone can see the presentation. All right, so I'll begin. Thank you very much for joining in today. I hope everyone's having a really good summer. For those of you who don't know me, my name is Chris Glover. I'm a senior account executive here at Airxchange. And the topic of the discussion today is going to be Airxchange plate introduction, as well as a brief overview of the selection software after I go through the presentation slides. And once again, I hope everyone's safe and having a good summer, and we'll get started. Okay, so on the agenda today for the presentation, I'm going to kind of go over the company overview, a little bit about Airxchange. I'll then discuss some of the AHRI and key performance metrics in regards to energy recovery plates. I'll then go into an Airxchange plate product review and discuss some of the benefits that are associated with the design. And then I'll briefly go over the software and some additional resources that are available to you. All right, so Airxchange as a company was founded over 40 years ago in Rockland, Massachusetts. For those of you who don't know where Rockland is, it's just south of Boston, Massachusetts. I guess the most important thing right now is the Red Sox are in first place, so we have that going for us. But really what the company's been known for is we founded the use of synthetic materials for heat exchanger, for air-to-air heat exchangers. And that kind of translates to some of the dialogue that I'm going to have today here. We are a charter member of the AHRI ERV committee. We also are a member of the ASHRAE 90.1 mechanical subcommittee, the ASHRAE standard 62 ventilation committee, and a member of the TC55 energy recovery committee. We are a dedicated OEM component supplier, so we do not compete for air handling business. We just work on heat exchanger components, and hopefully we do that very well. We currently have over 300,000 components in the market, and that number continually grows year after year. As a company, we provide a full complement of components that are available, where we can provide choices of materials, choices of desiccants that we can use, choice of technology now. So whether you need an energy recovery wheel or an energy recovery plate, we can provide those. And in each of those choices of technology, we offer multiple performance paths. So we're going to give you different options in regards to what you want to size the equipment and what type of performance you want out of the equipment. And each of the designs that we offer to the market, or I should say all the designs we offer to the market, are AHRI 1060 performance certified. Okay, so for today's technical discussion, it's really just AHRI certification. So AHRI standard 1060 is the performance rating for air-to-air energy recovery ventilation equipment. Part of the certified ratings that you get as being part of that certification program is sensible effectiveness, latent effectiveness, supply and exhaust air pressure drop, exhaust air transfer ratio, a lot of people call it leakage, and outdoor air correction factor. It has recently changed. It used to be based on static operating points, but it's recently changed to certify a software certification model where it basically certifies as a range of operating conditions. So it's no longer based on static points, but more based on an operational window or a psychometric window of operation. So you get a better, more thorough test of the equipment, as well as the reliability that you're going to be able to accurately operate this in a range of conditions. And they no longer, if you're part of the software certification portion, they no longer publicly publish the rating points, but they do publish the most recent software version. So you can just go to that the software provider's website and pull in that information, and that should be up to date. Okay. Sorry about that. I just heard a noise. I thought someone was chiming in. So in terms of the key performance metrics, the takeaways from being part of the program, the HRI program, a lot of people fall back on effectiveness. Effectiveness is the ratio of actual energy transfer, that's sensible, latent, and total, combination of both, to the product of the minimum energy capacity rate. And the maximum difference over the maximum difference in temperature, humidity, and enthalpy. A lot of folks have used this to kind of size and select their equipment. It can be a little tricky at times because depending upon what version of the definition of effectiveness you're using, it may or may not take into account the psychrometric change due to leakage. It's also not balanced to the supply side of the equation. So, in theory, you can actually have a very effective device, but you're not getting a whole lot of work out of it, depending upon how you have your airframe set up, or if there's a significantly leaky device that you're working with. A more recent term that's being used is enthalpy recovery ratio. This is referenced in ASHRAE 90.1, which is the energy standard. And it's actually the value that you would use to make sure that your device is in compliance with the energy recovery portion of 90.1. And really what it does is it takes the effectiveness definition and weights it to the supply side and takes out the change due to psychrometric leakage. Or the psychrometric change due to leakage, I should say. So it really accounts for basically the work that the device is doing on the actual conditioning of the air that it's providing. And it's just it's a newer metric, and it's one that I like to point out because it's one that's probably going to be used quite a bit in the upcoming future. All right, why aren't you sliding over? There you go. Exhaust air transfer ratio, EATR. A lot of folks refer to this as leakage, and it's basically, in its basic sense, is the opportunity for a component of the airstream coming back into the exhaust side to go back into the supply airstream. The certification for this value is done based upon a tracer gas concentration. So the lab injects a tracer gas into the system, and then it measures a mass flow measurement to determine how much is actually transferred as the device operates. I'd also like to point out that regardless if it's a wheel or a plate, there is going to be a certain amount of leakage, albeit plates leak less than wheels, but there still is a small amount. So you have to take that into consideration when you're designing your system. And that value is going to be measured as a percentage. So as you can see an example, it's 2.5%. So it's 2.5% of what the total delivered airflow is to the space. Another value that's equally as important is OACF, or outdoor air correction factor. OACF is the ratio of the entering supply air as measured by the leaving supply air. And it's measured as a ratio, as you can see, 1.05. What I like to point out is that OACF is inversely proportional. So it's a reciprocal value to EATR. So as EATRs go down, OACF values are going to go up. And it's really this value that's going to be used to determine how to size your fan capacity. So if you're operating with a OACF of 1.05 in this case, you'd have to design your fan system to be 5% above the nominal ventilation rate to make sure that you're delivering the net ventilation air to the space. So it's a very important value to take into consideration when looking at the system parameters of the ERV component. All right, so let's go right into some of the product review. very often, it's not very often I get to talk about products. It seems like most of the time that I'm on these things, I'm talking about technical and application specific stuff. But it's a good opportunity to kind of introduce you to some of the things that we can offer to the market and what some of the differences and benefits that they may have. So currently we have 3 different energy recovery product lines. Let's start with the Sequoia. The Sequoia is our legacy product. It's the one that we've had for the longest period of time. It's made of a porous membrane. It's a fiber-based membrane. It's a total enthalpy device. So it's going to do a portion of sensible and latent heat transfer. We currently have stock sizes of 275 millimeter to 1100 millimeter end caps, and I'll kind of go over some of these definitions in a little bit. So we have a standard product offering of up to 4,000 CFM in this size. We do have a significant amount of standard end cap sizes, but we can offer custom sizes depending upon the application and what you're looking to do with the product line. And we have multiple performance profiles once again. So you're not stuck with a singular performance curve. We can offer different densities so that we can provide different performance to pressure drop ratios to meet the need of the application or meet the need of the design of the cabinet that you're going to put these in. Plates are stackable, so typically when you look at increasing performance or airflow capacity, you kind of design to have one more singular core. You can stack plates side by side to increase the surface area and the volume of airflow that will be going over that surface area. And all of the products that we offer are both AHRI and UL listed. The Acadia is our newest, and it's a polymer membrane. So I thought there's a lot of synergy there between the new polymer membrane plate that we offer and the polymer wheels that we've been offering for a very, very long time. It can be either sensible heat exchange. It can provide either sensible heat exchange or total enthalpy, depending upon the application. We offer, once again, stock sizes of up to 275 to 1100 millimeter end caps. One thing that I'd like to point out in context of this conversation is that we stock the same end cap sizes for both our porous membrane and a polymer membrane. So if you're designing a cabinet for one, you basically have access to both depending upon the application. So you're not kind of limited to one technology versus the other. Once again, we have standard offerings that can go up to 4,000 CFM. I'll just, like I said, once again, we do have a certain amount of stock sizes that we can offer, but there is, the availability if there's a certain market or a certain volume we're looking to reach, we can offer custom sizes based upon, whatever feedback we get. They are stackable just the same way the porous membranes are, and once again, they are HRI and UL listed. Our last plate is kind of unique. It's the Sedona. Once again, it is another polymer membrane. It's our sensible only high efficiency plate. It's a cross counterflow in lieu of just the counterflow devices. So it provides a relatively high sensible effectiveness in a very small footprint. We have a standard offering up to 400 CFM. So this is kind of relegated to some of the light commercial residential markets. And it is HRI and UL listed. Okay, to go into some of the plate design features of the products that we offer, all of the plates are high structure plates, meaning that they can withstand a significant amount of pressure drop, as well as pressure differentials. In cases up to 5 inches of water gauge, so it's a significant enough. They're very structurally rigid and durable. All the materials do not deform under high humidity applications, so this is works well if you're going to be working in a coastal environment or in an environment of the country where there's a very high moisture load. They do have an antibacterial coating as well as a UV resistance. Going on my soapbox for a second, I'm not exactly sure why you'd put a UV light in the energy recovery component. The jury's still out on that, but once again, if you wanted to, it is UV resistant. So the feature, the maintenance features of each of the plates, the Sequoia model is what we call our cleanable model. So you'd use a vacuum and a brush to clean that one. The Acadia, which is our newest polymer model, is fully washable. So you can submerge this plate in water to clean it, And that kind of has some synergy with our polymer products and provides similar benefits that our polymer wheels would provide. Where if this is going to be in a dirty application or in an application where it's going to get fouled at a quicker rate, you may have an opportunity to give something that's a longer lasting, more maintainable to your customer through this process. And lastly, our Sedona product, which is the high effectiveness sensible product, that's once again fully washable. That product really was kind of developed hand in hand for the cannabis market, which is kind of growing, and a large amount of organic particulates that are in the air. They wanted a particularly heavy duty, durable, washable plate, and that's what we came up with for that market. Not saying that's limited to the cannabis market. I could see that being used in really any application where you have a very high heating load on the building, or any area where you want to try to have a very high sensible effectiveness. Okay, I'd like to mention we are the exclusive technology partners for Gayon, so our plates do come from South Korea, and we actively manage and test for the North American market compliance. So we do a lot of work with them to bring these products to market. So we handle all the UL certification, AHRI certification of these products, as well as any and all the stocking and distribution requirements for all North American OEMs. We do all the software development and compliance with any major certifying body in the North American market. So it's a significant amount of work we do, and it's a great partnership between two companies. And so let's discuss quickly some common energy recovery plate design terms. So you may have heard me mention this earlier, NCAP. The NCAP refers to the metal plates that kind of encapsulate the energy transfer media. So it's a sheet metal cap that's on top of the plate. Stack length is the length of the heat transfer media when measured from NCAP to NCAP. So it's the amount of heat transfer, or the length of heat transfer media that's going to be in the airstream. And media spacing, and media spacing, as you kind of see in the picture from the right there, it's really the open distance between the individual layers of media measured in millimeters. So the tighter the media spacing, the more thermal or the more effectiveness you're going to get out of the system, but the higher the pressure drop is going to be, and vice versa. As you open up that media spacing, you're going to lower the pressure drop, but you're going to lose certain effectiveness in context with that. All right, so we've developed Airxweb, which is our Airxchange selection software. It's our one-stop shop for energy recovery. So regardless of what component you're looking to size and determine the relative performance, you can go to Airxweb to get it. So it's going to have all our HRI certified wheels and all our HRI certified plates under one platform. The entire product line can be found at Airxweb.com, and what's nice about having a cloud-based platform, it provides kind of real-time performance prediction based on our HRI certified values. So you're always using the most up-to-date, relevant information, and not only from our HRI perspective, but also the weather data that we pull in. We bin all the weather data on the fly within the program. So once again, you're always using the most up-to-date information. It allows you to set custom operating schedules, so you can take a look at what the annual performance for these devices are going to be. Once again, it uses the latest bin data, and we take that from NOAA and ASHRAE worldwide weather stations. So we have access to their entire database of weather stations. It's a significant amount of data to crunch, but it provides you with a with a really good overview of how these devices are going to operate based upon, once again, the most significant, the best information available. You don't necessarily have to know the size of the component that you're looking to select. So we allow you to select based on either size, if you know it, or any type of performance metric. So if you're looking to size, based upon meeting a certain leaving air temperature, or minimum effectiveness, we give you options on how to query this data, so that you can make the selection based upon the parameters that mean the most to you. It saves it in the cloud, and it allows you to collaborate and share selections with other users in the cloud. So if you're using this software within an organization, you can kind of pass and share information with one another. And another thing about being, once again, in the cloud is all the information is backed up and stored online. So you don't necessarily have to store it or worry about data corruption. It's always going to be there right when you need it, whether you're in the office or out, most people are outside the office these days. So it's, it's a good feature to have. And lastly, I highly recommend, if you get an opportunity to go to our website. We've done a lot of work to put this website together. There's over 40 years of marketing and technical resources that's at airxchange.com. And this includes all our catalogs, our brochures, white papers, peer-reviewed technical articles, some of which were authored by us, some of which were just authored by others in the industry that are relevant to energy recovery, as well as application documents, case studies, educational resources. We also have service videos, maintenance videos. So if you're outside and you have an application where you're working on one of our devices, most likely we have a video that kind of demonstrates what you should be doing to service and maintain these devices to ensure a good long life expectancy. All right, so I'm going to keep this slide up here, and I'm going to kind of dive in to our software program. So I just kind of open it up right now. Does anyone have any questions before I kind of switch over to the to demonstrate the software selection? I'll just open up the chat box here real quick. You can just type it into the chat box if you do have any questions at this point. All right, it doesn't look like anyone's typing, so once again, I can kind of, I'll open it up once again at the tail end of the presentation to kind of go over any questions that you may have. So let me just open up the software here. All right, you should be seeing our Airxweb software. So you would just go to airxweb.com. I believe all I'll ask you for is your email address and a password, so it's just some very basic information. You'll see that when you enter the software, we have tabs that you kind of work through, starting with a new project. Let's go right there. Oh, I think I'm hiding here. Hold on. All right, sorry about the wait there. Okay, so let's create a new project that we're going to select a couple plates in. So once again, it operates from going from the leftmost tab over to the right. So we'll just include a new project. There you can see my many projects that I've been working on. We'll put in some very basic information here. And I'll choose Boston, Massachusetts for the location. It allows you to select your units of measure from inch, pound, or SI. I'm going to keep it inch, pound for the time being, as well as your humidity ratio units. And I will select Boston as our city. But here you can see where you can select the worldwide weather data. So we can select North America. We can select basically any continent that you're working in, as well as localized weather data based upon the weather stations that are in that area. We can use AHRI standard conditions as well as the selected conditions for ASHRAE. I'm just going to keep it at standard conditions for now. You can also use custom conditions, so you can put in whatever operating conditions that may be applicable to your particular project. We can add more project settings if we want, where we can take a look at changing the fan system around, adding standard different pressures. Here you can see we can use the different bin hours, full year, U.S. work week, U.S. school week, as well as create new bin hours for the schedule. So there's a lot of flexibility that's kind of built into creating these projects, and we try to create it or put it together in a user interface that has as minimal amount of steps required to get you to an output, but it really still has all that flexibility being built into it. So we'll create this project. Yeah. Oh, that's why. So I must have been doing something very similar earlier. There we go. Okay. So let's go and open up our new plate selection. And we're going to add plates to this project. Okay, so this is the plate selection screen. From here, you can see we can add unit tags, change the outside airflow, as well as get a dimension, some basic dimensional information about the plate. Let's start with a very basic selection. Let's use the new polymer cores. So we have your selection being paper or polymer in this particular case. So I'll start with polymer. You can see our stocked end cap sizes here. Now, there's really two criteria for selecting a plate. One is you're working with an existing OEM and they already have their own designs kind of in place. So that's kind of easy. You would just take those plate sizes and plug it into the information here. Or if you're working on a relatively new design, you can go back in here and make selections, not necessarily based on any given size, but what would be relevant to your design. So the 550 495 is probably one of the most common sizes in the market for plates these days. It gives you a good amount of options when developing either a new design or most likely working with an existing design. For this particular case, I'm going to keep it at the default selections. Once again, plates are somewhat scalable in nature when you stack them side by side. Here you'd be able to make the number of exchanges end-to-end, number of exchangers end-to-end, I should say. But we'll keep it simple for this particular selection. Once again, the design conditions we're going to keep at HRI conditions. You could change it to user supplied conditions or really any other condition that you'd want. You'll notice when I make these selections that there's a letter next to the end cap sizes. So that letter refers to the spacing between the individual media layers. So these are our standard sizes. You can see it's at 2.5 millimeter is our plate spacing. Let's say if we go to 1,000 millimeter end cap, this is an E spacing, so it's 3.1 millimeter. So basically, you'd make your selection, and that's good to be aware of before making these selections. So after you make all those selections, you can see that the dimensional chart has been updated on the right here. So it gives you your end cap sizing in these X dimensions, as well as your stack length, which would be your Y dimension here. Here you can see these are your operating conditions for your plate. These are counterflows. So once again, it's kind of a diamond shaped with a counterflow pattern. Because we're using HRI standard conditions, these values are kind of blocked out, but if you wanted to, you could add user entered information here. We use some default operating pressures. Once again, these pressures are defaulted to these values. You can change them to whatever you want that's going to mimic your design, as well as the ability to toggle fan positions. Let's calculate this particular plate. And it's going to populate this information below to kind of give you, what this plate is going to provide in terms of operating performance. So you can see we have our effectiveness values to the left, as well as our design loads and reduction on that design, which is the recovered load, on the right. From here, if you liked what you see, you can hit add to project, or if you wanted to change the performance of these devices, you can go back in and make some changes. Typically when you're looking at plate sizing, because they scale by the cube, they're not necessarily just by the diameter like wheels. There is going to be some kind of give and take when you're looking at designing these. Should you consider smaller cores versus multiple of smaller cores to maximize airflow, or should you be looking at a larger stack length, or possibly a larger end cap? I will say that as the end caps grow larger and larger, so does the pressure drop typically. So sometimes it's a little bit more beneficial if you have the opportunity to do in your design is to select a smaller end cap size, but just have multiple cores to maximize the area of airflow across the heat exchangers. But once again, there's going to be a little bit of kind of balance between those designs. If you have any questions, you need some guidance based upon a particular design, always reach out to us. We're happy to help to take a look at the design, and we can kind of give you some guidance on what might be the best combination of plate to the amount of air you have available in your cabinet. Or if you have any other particular selection criteria that you're looking to meet, you can probably provide guidance in that manner as well. Great. So, we added to the project. From here, we can add more to the project if you have multiple different units operating multiple different CFMs. To kind of keep it simple, we're just going to keep it at one right now. And then once again, you move from the leftmost tab to the right. Here we can go into your annual energy savings. So once again, we can calculate the energy load and the recovered energy load that this device is going to provide for the year. We've been this on the fly once again. So, based upon what we have here, you can see that I selected a 24/7 application. So, we have a lot of heating hours in Boston. We're typically a heating market. So here you can see, where the big benefit is going to be for using this device. It's going to be in the heating season for the most part. So this is your ventilation load, or what would have been your ventilation load. And here's your recovered load. So this is what the energy recovery component is doing for you, and what the net ventilation load is. So here you can kind of get the value proposition for using these devices and the energy proposition. We also include an economic analysis. I do like to say that the economic analysis is purely operational. It doesn't take into account any type of downsizing from the system that would happen, when you incorporate these devices. That's not necessarily saying that you should disregard that benefit, but what we look at is just merely the operational savings. So here you can calculate the economic value for having these devices. So here you can see for this particular device, what the cooling dollar saved would be, what the heating dollar saved would be, and what your net savings would be for using this component. You can change and update your efficiencies and utility data. So here you click here. So say your system's more efficient or less efficient, you can make that determination here, as well as your utility costs. We kind of defaulted to 10 cents a kilowatt hour and $1 per therm, but here you can, if you're in an area where it's cheaper, and let's be honest, these days, I hope we're all in an area where things are cheaper, because things are just a little bit crazy right now. Here you make those changes, and then you would just kind of continue going from the left to the right. And then lastly, if you like everything that you see here, you can generate a PDF report. So here's your options for all your report options that you can include. You can include the bin energy analysis. I like to include the summary. Bin energy analysis includes basically a bin for each unit. Your annual economics analysis, 2D drawings, as well as your design point analysis for each of the components that you have selected. So for this particular unit, we're just going to click print report. It's going to go back and save everything and develop a report for you. Typically takes about 15 seconds, once again, because we kind of aggregate and bin everything on the fly. I also like to point out, while it's going through this, is we can also include wheels and plates together. So if you have a mix and match of technologies on the website or on your design, you can do that as well. So here you see all the information, kind of going into the design point analysis. Here you'll see everything that's kind of relevant to the design of this plate. So once again, you made your selection. One thing I didn't point out is frost control. We do have frost control built into our selection software. So if you're in the area of a country where that's may be a concern to you, that gets included. Under the HRI standard conditions, there's no frosting under those conditions, but if you were to put in operating conditions where a frosting condition would occur, it would automatically tell you that this is something that you need to take into consideration based upon those operating conditions. So once again, it tells you your HRI effectiveness, as well as your energies at design conditions. So here you can see the operating conditions, so you're entering and leaving conditions based upon the selected criteria. Also, once again, I think this is kind of important. Here you see enthalpy recovery ratio and sensible recovery ratio. So once again, it's a newer term. It is a term that's used in 90.1. So if you're trying to remain in compliance with the energy recovery portion of 90.1, this would be the value that you'd be taking into consideration to make sure that you're meeting that criteria. So we separate it by summer and winter operations. If you had multiple units, it would be included in a design point summary, so you can get all this information at a glance. Here is a kind of your economic and operating schedule summary, so everyone knows how you design this unit, as well as your bin source or bin energy analysis, which is based upon the schedule that you entered. Your economic summary as well. So it kind of aggregates all that information and puts in a nice clean report for you to use. And you can either save this as a PDF, download it. But what I really like to kind of to demonstrate and to mention is this: it's really your one-stop shop. So regardless of you're using polymer wheel, whether that's sensible enthalpy, if you're using a plate, sensible enthalpy, you really have options in the software, and everything is all located under one platform, and it includes all our HRI certified components under the kind of this one software umbrella. So it really is quite flexible, and I hope you get an opportunity to use it. So with that, I know it's a kind of a quick overview. I hope you get a chance to use it. Feel free to kind of send us feedback as you're using it. We want this to be very user-friendly, and hopefully we provided a great tool for that you can use out in the marketplace to work with these components. So with that being said, I'm going to switch back over to the chat box here to kind of open up for any particular questions, and we'll address them as they come in. So let me have here, and then I will open up. Okay, there's my contact information in case you need to get a hold of me. But let me open up the chat box and see if you have any questions. If you don't have a question and just going to be leaving us now, thank you so much for joining in. We appreciate you taking time out of your day to be here, and hopefully you get a chance to go chime in on our next webinar.